Good morning all. This is mathematics class of grade 8 and this is my lecture number 7 of chapter number 9, Algebraic Expressions and Identities. Basically this will be your summary lecture and the concepts which will be left in this lecture will be covered in the next lecture. Let us see what we will be covering in this lecture, and as far as the chapter Algebraic Expressions and Identities, what are the topics which we have covered in this chapter number 9, Algebraic Expressions and Identities. Basically, first of all, we have learnt the definition of algebraic expressions, and we have learned the different operations, how to operate algebraic expressions with different operations like addition, subtraction and multiplication. And then in this chapter we have covered identities topic also. So as far as this chapter is concerned, we are supposed to basically deal with algebraic expressions and the various operations performed on the algebraic expressions, and then we need to know what do you mean by identities, or what are the different identities we need to use. Now in this lecture number 7 we will be covering the definition of algebraic expressions and subtopics like constant, variable, factors, constant term, coefficient, algebraic expression, what are the types of algebraic expressions, what do you mean by a polynomial, how to find the degree of an algebraic expression or a polynomial. These all topics along with the addition and subtraction of algebraic expressions we will be covering in this lecture number 7, and then after that in the next lecture I will be talking about identities and multiplication topic which will be left from this chapter. So basically in algebra we use two types of symbols, constants and variables, and the other name of variables is literals. What do you mean by a constant? A symbol which has a fixed value is called a constant. For example, 7 minus 3. Here I have written two examples. There can be many more, like square root of 2, that is under root 2, 2 minus root 3, pi, 2 over 5, that is a rational number, 2 by 5, minus 7 over 2. All these come under the category of constants. Then what do you mean by a variable? A symbol which can be given various numerical values is called a variable or literal. So in algebra basically we use two types of symbols, constants and variables, and the other name of variables is literals. What do you mean by a constant? A symbol which has a fixed value like 7, minus 3, 2, minus root 3, pi. These are all having fixed value. Their value cannot be changed. So that is why they come under the category of constant. What do you mean by a variable? A symbol which can be given various numerical values is called a variable or literal. Literal is the other name of variable. Now, coming to algebraic expressions definition, what do you mean by an algebraic expression? A collection of constants and literals or variables when they are connected by one or more operations of addition, subtraction, multiplication and division is called an algebraic expression. So basically algebraic expression is nothing but it is a collection of constants and literals or variables which are connected by one or more of the operations of addition, subtraction and multiplication and division. For example, 2a plus 7 and 7y minus 3 plus 60. Here 2 is a constant, or here if I talk about this term 2a, 2 is the numerical coefficient, a is your literal coefficient, and these are the collections of constants and literals. 7 is your constant term. By how they are connected together? They are connected together by plus sign. Likewise in this term also 7y minus 3 plus 60, here constants and literals are there present in the expression and they are connected by plus or minus sign. So these two examples are the examples of algebraic expressions. Now, the various parts of algebraic expressions separated by plus or minus sign are called terms. If I talk about the above two expressions, in the first example, 2a is your one term, 7 is your another term. As it is written there, the various parts of the algebraic expression separated by plus or minus sign are called terms. In between plus sign is there, so 2a is your first term, 7 is your another term. Both these are separate terms. 7 is rather a constant term. Now, types of algebraic expressions. We have divided algebraic expressions on the basis of number of terms present in an algebraic expression. First one is monomial. What do you mean by a monomial? An algebraic expression having only one term is called a monomial. Binomial, bi means two. So, an algebraic expression having two terms is called a binomial. Trinomial, what do you mean by trinomial? An algebraic expression having three terms. That is, tri means three. So, it is a trinomial. And multinomial, an algebraic expression having two or more terms is called a multinomial. I hope the types of algebraic expressions are clear to you. First one is monomial having one term, binomial having two terms, trinomial having three terms, and multinomial having two or more than two terms comes under the category of multinomial. Now, let us see this table and we will come to know the terms and how many terms are present. According to that, I have given the name to the algebraic expressions as we have learnt the various types of algebraic expressions. First is minus 8a square. Number of terms 1. So, if an algebraic expression having only one term, what is it called? It is called a monomial, and term present is minus 8t square. Now, coming to second example, here as I told you that the various parts of an algebraic expression, they are separated by plus or minus sign and they are called the terms. So, here in this second example, this is your first term and along with minus sign, that is minus 3x, it is your second term. So, the number of terms are 2, and an algebraic expression having two terms, what is it called? It is called a binomial, and the terms are 5x square y and minus 3x. Simple as this. Now, coming to this third example, it is 9x raised to the power 5. This is your first term. Minus 3x square, this is your second term, and 4 is your last term, that is the constant term. So, number of terms are 3, so it is called a trinomial, and separately I have written the number of terms. I hope this is now clear how to find the number of terms, and on the basis of number of terms, we have given names to the algebraic expressions, that is monomial, binomial, trinomial or multinomial. Now, another point to note is multiplication and division do not separate the terms of an algebraic expression. What does it mean? It means that if with the help of this example, you will be able to understand, like minus 7x square y cube, if you will see or if you will think that there is a multiplication sign between all these minus 7x square and y cube, but this multiplication and division sign, they do not separate the number of terms of the algebraic expression. So, this will be considered a single term, that is a one term. Whereas, this minus 7x square y plus or minus sign, they separate the number of terms. So, minus 7x square y cube plus y cube has two terms. This is your first term, and after plus or minus sign, another term will start. So, this will be your second term. So, there are two terms in this expression. This is an expression now because it is connected by plus sign, and it is a combination of or collection of constants and literals. Now, what do you mean by a constant term? It is very simple. The term of an algebraic expression having no literal factors is called a constant term, and we have seen or we have learned which has a fixed value, that is a constant term. And in the expression minus 3a square b square plus 5ab minus 7. Minus 7 is your constant term because there is no literal factor attached with this term. Simple as then. In the first term, a square, b square are the literal factors. In the second term, a and b are the literal factors. So, along with minus 7, there is no literal factor. So, this is a constant term. Now, what do you mean by factors? Each of the quantity, constant or literal, multiplied together to form a product is called a factor of the product. Means that there are two types of factors. One is numerical factor and another is literal factor. So, constant factor is called a numerical factor and a factor containing only literals is called a literal factor. So, each of the quantity, constant or literal, when they are multiplied together to form a product is called a factor of the product. And there are two types of factors. One is numerical factor or a constant factor. It is one and the same thing. Literal factor, a factor containing only literals is called a literal factor. Let us understand this with the help of example. In 8xy square, in this term, the numerical factor is 8. This is your numerical factor. 8 is the numerical factor and literal factors are x, y, y square, xy and xy square. Basically, you are supposed to break the literal factors, that is x, y, y square, xy and xy square. So, numerical factor is 8 and literal factors, literal factor it is xy square, xy, y square, x or y. I hope this is now clear to you. Now, what do you mean by coefficient? Any factor of a non-constant term of an algebraic expression is called the coefficient of the remaining factor of the term. To understand this term coefficient, we need to take an example which I will be covering in the next slide. So, by the time just have a look on the definition. Any factor of a non-constant term, the term should be non-constant, of an algebraic expression is called the coefficient of the remaining factor of the term. The constant part is called the numerical coefficient or the coefficient of the term and the remaining part is called the literal coefficient of the term. So, what does the constant part called? It is numerical coefficient or the coefficient of the term and the remaining part is literal coefficient of the term. Let us understand this with the help of an example. In this, I have taken one expression. This is an expression. Now, you can take any term. I have taken this middle, this term, that is minus 8t square a. Now, using this term, I will be telling you what is the numerical coefficient of this term, what is the literal coefficient, or if the coefficient of any other variable, if it is asked, then I will be making it clear to you. For example, now, in this term, the numerical coefficient is minus 8. So, it is clear, like if I talk about this term, what is the numerical coefficient of first term? 13t cube a square. 13 is the numerical coefficient. If I talk about this term, minus 3t, what is the numerical coefficient of this term? It is minus 3 and 2 is the constant term obviously. So, literal coefficient of this example of this term is t square a. Coefficient of t square, apart from t square, whatsoever it is present in the term, that will be your coefficient of t square. So, if I leave t square from this given term, that is minus 8 t square a, if I leave this t square, what will be left? Minus 8a. And the coefficient of minus 8a, if I want, what will be left after leaving minus 8 and a? That will be t square. So, in a given term, if I need to take the numerical coefficient and literal coefficient using this example, I hope it will be clear, and this is what you will be using in the multiplication of algebraic expressions. So, I am repeating it. For example, in this expression, I have taken this term, that is minus 8t square a. The numerical coefficient of this term is minus 8. Literal coefficient is t square a, every time you are supposed to take minus sign with the numerical coefficient. So it will be minus 8, the numerical coefficient, literal coefficient apart from minus 8, whatsoever it is present, that will be your literal coefficient, that is t square a, or the variables which will be present. The coefficient of t square apart from t square, whatsoever it is present, it is minus 8a. So it will be the coefficient of t square. And the coefficient of minus 8a is equal to t square only. I hope this is now clear. Now let us note the points. If no coefficient is written before a literal, then the coefficient is always taken as 1. When we write x, we mean 1x. So whenever I need to tell the coefficient of this x, any literal, then it will be 1. The numerical coefficient of it is 1, so it will be 1x. It means if we are writing a single variable, it can be x, y, t, a, b, whatsoever it is, but the numerical coefficient, it will be 1a, 1y, 1x here in this example like. Now coming to like terms and unlike terms. What are like terms and unlike terms? The terms having same literal coefficients. We have understood how to find the literal coefficients. So now like terms, these are very easy to understand. The terms having same literal coefficients are like terms. Otherwise they are called unlike terms. Simple as this. Let us see with the help of an example. In this example, 3a square b square. Here it is a square b square. It is the literal coefficient. A square b square. It is the literal coefficient. So these are like terms. Whereas it is in this 7ab, 8t square v square, literal coefficients are different. Here it is ab and here it is t square v square. So these are unlike terms. And there is no difference if in place of 3ab, 3ba is present, that is also one and the same thing. ab or ba, it is one and the same thing. These are the like terms. 3ab or 3ba, these are considered as like terms. Now coming to polynomials. What do you mean by a polynomial? An algebraic expression is called a polynomial if the powers of the variables involved in each term are non-negative integers. Basically, we are supposed to look at the powers of the variables present in every term, and those powers should be non-negative integers. If they are negative integers, then they will not be considered as polynomials. And a polynomial may contain any number of terms. It can be one or more than one. Now to find the degree of this, we need to take the sum of the powers of the variables in each term, and the greatest sum is the degree of the polynomial. First of all, you need to check whether the expression is a polynomial or not. If it is a polynomial, then you need to find the degree of that expression, polynomial. So let us take an example to understand the concept of degree. Let us take an example. This is 39t plus 5. And to find out whether an algebraic expression is a polynomial or not, we need to check the powers of the variables present in every term, and they should be non-negative integers. Here this is the term 39t, and t is the variable present in it. What is the power of t? That is 1. It is positive. So, and this term is a constant term. So these two terms are satisfying the condition of a polynomial. So we can say that this is a polynomial. How many terms are present? 2 terms. That is 39t and 5. These are 2 terms. And what is the degree? What is the power of the variable present in first term? That is t raised to the power 1. So the degree is 1. And the last term is 5. That is a constant term. No variable was present. So according to one term, that is the first term, we have calculated the degree. Now coming to second example. In this, first of all, check it out. What are the number of terms? This is your one term. Minus 7ab square. This is your second term. And 3 is the third term. So number of terms are 3. Whether it is a polynomial or not, the power of a and b in this first term, both are positive. So satisfying the condition. In this second term, again a, b square, a power of a is 1, b is 2. Again it is satisfying, both are positive integers, so satisfying. This is a constant term, so again it is satisfying. All the 3 terms are satisfying, so we have said that it is a polynomial. Now how to find the degree? In the first term, what is the sum of the powers of the variables? It is 3. A is 2, B power is 1. So 2 plus 1 is 3. Now if I talk about second term, what is the power of A? 1. What is the power of B? 2. So total is 3. So the degree is 3 only. Highest, though these two powers are equal, of the sum of the powers of both the variables in both the terms are equal, so the degree is 3. Now we have understood this second example. Now let us see third example. It is 10a plus 5 over b plus 2. It is not a polynomial. Why? Because in this second term, it can be written as 5b raised to the power minus 1, and the power of b is a negative integer, so it is not a polynomial. Rest two examples are polynomials, and this third one, it is not a polynomial. Now coming to addition of algebraic expressions. When we add two algebraic expressions, we can only add like terms. This is quite obvious, and we have understood how to find out the like terms. The terms having same little coefficients are called like terms, otherwise they are unlike terms. And sum of two or more terms, like terms is a like term. Obviously, if we are adding like terms, we will be getting the sum as like terms with the numerical coefficient equal to the sum of the numerical coefficients of all the like terms. Let us understand this now. And to add two or more algebraic expressions, we may use horizontal method or column method. I will be showing you horizontal method as well as column method for addition as well as for subtraction. Now, I need to add these three expressions. I am first explaining horizontal method. Horizontally, I need to write all the expressions. This is what I have written here. As I need to add, so I have put addition sign in between these three expressions. This was the first expression, this was the second, this was the third, and I have written plus sign as I need to add. Simple as this. Now, I have written what I have done. I have taken like terms. I have written like terms together. So 3x square minus 4x square, these are the like terms. Minus 5xy minus 9xy plus 7xy, these are the like terms. 4y square plus 7y square plus y square, these are the like terms. I have written them together. Minus 1 plus 5 minus 13, these are the like terms. Now their literal coefficients, that is x square in the first term, will remain same, and the numerical coefficients will be solved. Like 3 minus 4 will give you minus x square, minus 1. As I told you, whenever no numerical coefficient is written, we are considering it as 1x, as I told you in the previous slide. So 3 minus 4, it gives you minus 1. So I have written minus 1x square. Minus x square. Now after solving, minus 5 minus xy will be written as it is because it is present in all these three terms. These are like terms, so I have written xy as it is. Now numerical coefficients will be solved. Minus 5 minus 9 plus 7, it will be giving you minus 7. So I have written minus 7. Now after solving these three like terms, what I will be getting? Solving the coefficients, 7 plus 4, 11 plus 1 here, because I told you if nothing is present, we are taking it 1 as the numerical coefficient. So it will be 12y square. And after solving the constant terms, we will be getting minus sign, so which is the required sum. Now explaining column method. Here in the column method, we need to arrange the like terms in such a way that they are one below the other. Like these three expressions were given in the question. What I have done, I have written the like terms in such a way that they are one below the other. Like below 3x square, I have written minus 4x square because these are like terms. Likewise here also I have written the like terms. In this column, in this, everywhere I have written the like terms in such a manner they are one below the other. Now as we have solved in the previous case in the horizontal method, similarly you are supposed to solve the numerical coefficients and you will be getting the same answer. Any method you are using, you can use any method, answer will remain the same. Now coming to subtraction of algebraic expressions. To subtract algebraic expressions, change the sign of the algebraic expression to be subtracted and then add. We need to change the sign of the algebraic expression which is to be subtracted and then add. We know in subtraction we need to change the sign of the algebraic expression and then add. We may use horizontal method or column method as we have done in case of addition. Let us do this example now. We need to subtract this expression from this expression. So this expression will be written first and then afterwards this expression will be written. As it is written, we need to subtract this expression from this expression. So I am first explaining horizontal method. Horizontally I have written. Now this expression remain as it is because this was the expression from which I need to subtract, and as minus sign is there outside the bracket, so I have changed the sign of every term which is present inside the bracket. Now it will be minus 5x cube. Earlier it was minus, so it has become now plus because minus sign is present. Now minus minus, it will be giving you plus 8. Now solving the like terms or rearranging the like terms. I have rearranged the like terms in this step. 2x cube minus 5x cube, I have written them together. Minus 5x square plus 3x square written together. Minus 11x, it is written all alone because no other term is present of x variable or x literal coefficient. So it is written as it is. 8 and 2 are the constant terms, so written at the end. After solving the numerical coefficients, you will be getting minus 3x cube, minus 2x square, minus 11x plus 10. This will be your answer. Now in this column method, we need to change the sign of the expression or each term to be subtracted and then add. So what I have done, I have changed the sign here. Those terms which were positive, I have made them negative, and those which were negative, I have made them positive, and you will be getting the same answer. Now homework from NCERT. Dear children, you are supposed to complete question number 2 to 4 of exercise 9.5 in your homework notebook. And in this chapter, we have revised all the concepts from the beginning of this chapter, like definition of algebraic expressions, constant, numerical terms, numerical factors, literal factor, coefficients. Likewise, we have studied addition and subtraction of algebraic expression also. And rest part we will be covering in the next lecture. Now coming to the homework solutions from NCERT exercise 9.4. This question number 3 is simplify. This is the term, this is the expression given to you and you need to simplify it. So how will you be doing? Simply you are supposed to take the first term of first expression and multiply it with the second expression, like I have written here, x square into x plus 5. Minus 5 is the second term, minus 5 into x plus 5 plus 25. It is written outside the bracket. So I will not be multiplying it by x square. These two terms are to be solved. Plus 25 is written separately. So x square into x, it will be multiplied by every term, x square into 5. I have done it here. Minus 5 into x, I have written here. And plus minus 5 into 5 plus 25. So x square into x will give you x cube. This will give you 5x square, and minus 5x minus 25 plus 25, they are of opposite signs, so they will get cancelled out, and your answer will be x cube plus 5x square minus 5x. I hope this is clear to you. Now coming to fourth part of this same question. You are supposed to solve the expressions first and then do whatsoever is the requirement of the question, that is add or subtract. First of all, these two are to be multiplied and then these two are to be multiplied, and they will be added further to this expression. This will also be multiplied. 2 will be multiplied to AC, it will be 2AC, and 2 will be again multiplied to BD, it will be 2BD. Let us see now how to solve this. So what is the first step? A is to be multiplied by C minus D plus B into C minus D plus A of this first term is to be multiplied by C plus D minus B into C plus D plus 2AC plus 2BC. You can solve it here also. I have solved it in the next step. You can solve it here also. So it will be AC. This will be multiplied by A, and A will be multiplied to D also. It will be minus AD plus BC minus BD, these two will be multiplied, plus again first term, that is the term which is written outside the bracket, is to be multiplied by every term which is present inside the bracket. This we have seen in the till exercise in every question till exercise 9.4. So it will be AC plus AD minus BC minus BD. Every term will be multiplied plus 2AC plus 2BD. Now I need to arrange the like terms. So I have arranged the like terms and my answer will be 4AC. Let us see how. AC is present 2 times, AC plus 2AC, it will be 4AC. These two are of opposite signs, these will get cancelled out. These two are opposite signs, get cancelled out. Now 2BD and this will give you minus 2BD. So 2BD minus 2BD, these are of opposite signs, so they will also get cancelled out and your answer will be 4AC. So step by step if you will be doing, you will be able to get the correct answer. Simple, you are supposed to multiply every term which is present outside the bracket to every term, each and every term which is present inside the bracket along with the sign you need to take. Now coming to fifth part of the same question. Again, this is the same question. You need to solve these two expressions, and then rearranging the like terms, and then you will be able to get the answer. Like what I have done, x of this first expression is to be multiplied completely by this expression, plus y of this expression is to be multiplied completely by this expression. Similarly, x will be multiplied completely by this expression, 2y will again be multiplied completely by this expression. This is what I have written here. X into 2x plus y into 2x plus y plus x into x minus y plus 2y into x minus y. So it will be 2x square plus xy plus 2xy, y will be multiplied to both the terms, plus y square, y into y square, plus x into x square, plus x into y, x into minus y, it is minus xy, plus 2y into x, that is plus 2xy or 2yx, it is one and the same thing, plus 2y into minus y, it will be minus 2y square. Now rearranging the like terms, we will be getting, these two are like terms, they will be giving you 3x square. These two are the like terms. After solving the numerical coefficients, that is 1 minus 2, you will be getting minus 1. So here it is minus 1 y square, it is quite obvious. Plus xy, that will be giving you, these two get cancelled out because these are of opposite sign. So plus 4xy. Now coming to seventh part of this same question, again you need to solve in the similar manner which we have done in the previous slides. You are supposed to multiply each term of this expression with each term present inside the bracket of this. This is the complete bracket. So 1.5 into 1.5x plus 4y plus 3 minus 4y will be multiplied by this and this will remain as it is. So what is this step now? These two will be multiplied, I have written here. This will be multiplied to 4y, this is I have written. This will be multiplied by 3, this is what I have written. Now minus 4y into 1.5x minus 4y plus 4y minus 4y plus 3. This is what I have written here. The rest term I have written as it is. Now after multiplying, you will be getting, after multiplying these two, you will be getting 2.25 y x square. After solving next term, you will be getting, likewise you will be able to solve the next term and multiply till the last term. Like 1.5x into 3, it will give you 16y square. 1.5x into 4y. I am repeating it again. 1.5x into 4y, it is giving you 6xy. These two are giving you 4.5x. These are giving you, after multiplication, minus 6xy Minus 4y into y, it is giving you minus 16y square, and then minus 12y minus 4.5x plus 12y. Likewise, then you have arranged the like terms in this step. These two are like terms, these two are like terms, rest, these two are the like terms. Rest will remain as it is because there is no like term for other terms, so they will be written as it is. Now you will find that they are of opposite signs, so they will get cancelled out. These two are of opposite sign, these two get cancelled out, and these two are of opposite sign, so they will also get cancelled out, and your answer will be 2.25x square minus 16y square. Now coming to the homework solutions from NCERT exercise 9.5. In this question you are supposed to use the identities. This is the first part. X plus 3 can be written as x plus 3 whole square, and we have learnt the identities. So let us see the steps now. X plus 3, it is written twice, so I have written like this. Now I have written the I have seen the identities derivation, that a plus b whole square is equal to a square plus 2ab plus b square. Here in place of a, what is present? X is present, so I have written x square plus b, here it is equal to 3. So in this identity I have just put the values of a and b, and after putting the values you will be getting the answer as x square plus 6x plus 9. Coming to third part, now there is negative sign between these two. Let us understand the steps now. Dear children, in these questions you are supposed to find out which identity is to be used and simply use that particular identity and get the answer. 2a minus 7 can be written as 2a minus 7 whole square. Now as minus sign is present and we have identity number 2 in which minus sign is present, this is your identity number 2. So here a equals 2a and b equals 7. Already negative sign is there in the identity, so I will be writing b as 7 only. So putting the value in this identity number 2, what you will be getting? 2a square minus 2ab minus 2 into a, as I told you it is 2a, into b, that is 7, plus b square, that is 7 square. So you will be getting 4a square minus 28a plus 49. This will be your answer. Now coming to fifth part, in this question we are supposed to use the identity as I told you. Now first of all, look at this part. Here it is plus minus sign in between, here it is plus sign in between, and first identity we have a plus b whole square, second identity we have a minus b whole square on the left hand side, in the third identity we have a plus b, a minus b. So we will be using third identity in this question. Here let us see what is the third identity. It is a minus a plus b, a minus b. So it equals a square minus b square. Here a is equal to 1.1 m, b is equal to 0.4. So simple, use this result, that is a square minus b square. So 1.1 m square, it is 1.21 m square. 0.4 square is 0.16. Now coming to this sixth part, it is a square plus b square and minus a square plus b square. Let us see the steps and then I will be explaining. What I have done, can I write this as b square minus a square? Yes, obviously there will be no change. I have just shifted the position of a square and b square so that I can apply the identity number 3. Because I told you first plus sign is there between the terms and then minus sign should be there between the terms, and this is your identity number 3. A plus b, a minus b equals a square minus b square. Here a is b square and b is a square. So b square whole square is b raised to the power 4 minus a square whole square is a raised to the power 4. Now coming to the last part of this lecture or this exercise of this question, let us see now. I am writing the steps first so that it will be more clear to you to understand. Now look at this part. If I look at this part, it can be solved as like this. This is present twice, so it will be written minus a plus c whole square. Now plus sign is there, so I have written this identity number 1. Or if I write this as c minus a whole square, it will not make any difference. So you can use second identity also. I am using first identity because plus sign was there. So a here is minus a, b here is c. Basically you are supposed to compare the terms or the expressions with the identities. Like I have written a square, a plus b whole square equals a square plus 2ab plus b square. So it will be a square, that is minus a, plus 2ab, 2 bracket minus a minus c, and plus b square according to the identity I have written, and it equals a square. And if I am multiplying minus a twice, it will be positive a square, so it will be a square minus 2ac plus c square according to identity number 1. As I told you, you can use identity number 2 also, like minus sign can be written in place of this, because this can be rearranged and can be written like this also. So dear children, I hope you have understood these questions, and you are supposed to complete all the parts of every questions, because it is not possible to discuss all the parts in the lecture. So I have tried my level best to cover the important parts. Rest parts, on the basis of this explanation, you will be surely able to do. So please do all the parts of all the questions. Do like the video, and please do not forget to subscribe the channel. Thank you so much.